Good day, Philo. Setsu is back. Setsu is back. Today we are going to do an Aufbau diagram. An Aufbau diagram. For the sake of this video, we are going to consider magnesium, which has an atomic number of 12, atomic mass of 24. We have an atomic number as well, the atomic mass of 24. See, then now, before we can even continue, don't forget to start by your electrons. I know we have to be used to this. Electrons, we have atomic number. Don't forget this formula: atomic number minus a charge. We have a neutral atom, which is going to be 12 minus 0. There is no charge here. Then we get 12. Done. We have 12 electrons because it's neutral. You see, it's neutral, hence I put 0. Then now we use this strategy. We have 1s, s, s, p, p, d. S can take up to 2, P can take up to 6, D can take up to 10. Then we also need to include these arrows like this. See? Then for a spectroscopic notation, it's so simple. We follow these arrows. You see? I've already done it. But we follow these arrows, which is going to be 1s. You feel it? 2. You move to the second one, which is 2s, 2. You move to the third arrow, 2p, 3s. 2p can take up to 6, 3s can take up to 2. This is a spectroscopic notation. We follow these arrows: 1s, 2s, 2p, 3s, like that. 3p, but we don't need 3p because we only have 12 electrons. Then this is a spectroscopic notation. Then the noble gas will be from here to here. We consider this one till here, which is neon. Then you close, then the remaining is 3s2. You see, this is a noble gas, this is a spectroscopic notation. But I'm not here. We want to answer this question of an Aufbau diagram. Don't forget your principles. We have Aufbau principle. If I can even continue, let us revise some principles. We have Aufbau principle. We also have Pauli's principle and Hunds principles. We have these 3 principles. You see, I will use a simpler definition for each and every principle. An Aufbau principle state we start from lowest, then we move to the highest energy level. From lowest to high energy level. See? Then Pauli's principle state electrons spin in opposite direction. You'll see. Then lastly, Hans principle. Hans rule state electrons would rather be their own subshell before they share. See, before they share. The keyword spin in opposite direction from low to high, be on their own before they share. You see, now let us use the spectroscopic notation as a guide for us to do an Aufbau diagram for magnesium. I'm going to need 1s with 1 orbital, then 2s with 1 orbital, then 2p s3, then we write them like this, 3, then 3s, I hope you can see, only have 1 orbital. Then okay, we have these numbers. Let me take this one, which is 1s, and these small numbers here. These numbers, they represent electrons. This one a subshell. Let me say subshell or an orbital. Then this one represent what? Energy level. Energy level. See? Then yeah, we have electron, subshell, energy level. Then now let us fill our subshells now. Then firstly, for this one, for the entire thing, let me say entire thing, we use an Aufbau principle which states from low to high. We don't start from high then move down. We start from low, from 1s upward. Then we're going to fill 1. Then let us fill up again. In which direction will this arrow now point? Up or down? Clearly down. Why now? Because of Pauli's principle. We state electron must spin in opposite direction to face down. This. Then we have completed. Let us move to another one. Up, then down. See? Then now we have reached 2p. How are we going to fill 2p now? We use Hunds principle. We state electrons will rather be on their own subshell before they share. You see, we are going to start by filling each like this. Then we have completed, then we return back but in opposite direction. Now we have 10 so far. Let us complete our diagram. 1 1. Then we have how many now? 10 11 12. You see, they do correspond to that number. See, they do correspond to that number. Then you can then do like this. Then at this point we have then now answered what the question, which states draw an Aufbau diagram for what? For magnesium. You see, so simple. I hope you understood. Thank you, fellows, and enjoy.